ไม่มันจริงแล้วเหรอพี่ดวงแค่สุดแล้วเห็นมันเป็นตัวเลยจากโดถ้ามันนานเกินมันปรับไปตรงรับได้นี่เอาบอกเสียงไอ้แชมป์นะผมว่ามันต้องพอเองก็ต้องถูกมากที่สุดเพราะว่าเองจะเป็นพี่ต้องพูดตรงนี้ฮัลโหลฮัลโหลไม่ทำไมมันเขาจะก้องให้จัดมาถึงก็พูดฮัลโหลฮัลโหล
เทส
โอเค
เทสเทส
ทดสอบ
ฮัลโหลฮัลโหลโอเคไหมโอเคไหม
Theoretical physics is a branch of physics that deals with the development of mathematical models and frameworks to explain and predict the behavior of the physical universe. Theoretical physicists use a variety of mathematical and conceptual tools to construct models and hypotheses that describe the fundamental laws of nature and the behavior of matter and energy at a wide range of scales, from the subatomic to the cosmological. Theoretical physicists often work in collaboration with experimental physicists, who perform experiments to test and validate their theories. Together, theoretical and experimental physicists work to advance our understanding of the fundamental laws of nature and to explore the mysteries of the universe. Without our understanding of the underlying mechanism of the nature, all kinds of today technology would be impossible. For examples, communication networking, global positioning system, GPS, high-performance computer and magnetic resonance imaging. The Institute for Fundamental Study, or IF in short, was officially inaugurated on March 14, 2011 by Naresuan University Council as a research center unit. From the first day to the present, IF members are working on the cutting-edge areas of research in theoretical physics to expand the boundaries of our understanding of the fundamental laws of nature, including cosmology, gravity, string theory, quantum information science and mathematical physics. We would like to emphasize that frontier research in theoretical physics is essential for advancing our understanding of the universe and developing new technologies that would benefit not only Thailand but the world society.
Okay, good afternoon, everyone. Welcome back to the Tah Poe Seminar Series 56. And today is the talk number 1. It's the first talk by Dr. Pichet, Vanichchapongjaroen. And today he will tell us about double-dimensional reduction of M5 brane action in sense formalism. Please welcome our speaker.
Okay, thank you, everyone. Good afternoon, and thanks, Dr. Pongwit, for the introduction. So, yeah, as I said, my topic is double-dimensional reduction of M5 brane action in sense formalism, which is based on my work with my student. The work from last year, which is in turn based on my work in 2021. Okay, so I will actually first talk about M5 brane action in the sense formalism. First, just some part of it, and then we'll come to double-dimensional reduction of this action later. Okay, so yeah, I will spend some time to first talk about linear pseudo theory, and then go to nonlinear pseudo theory, which are basis for the construction of M5 brane. And then go to the covariant M5 brane action in Green-Schwarz formalism. And then after that, we'll talk about the double-dimensional reduction of the M5 brane action on the circle. And then also talk about some extensions which appear in my paper, but I'm not going to cover everything in my paper. So everything else is put in extensions, and then give a conclusion. Okay, so as a motivation, so this work concerns the construction of an M5 brane action, which is described by a 6-dimensional world volume, and which is embedded into 11-dimensional background supergravity target space. And we are interested in constructing the Green-Schwarz formalism. Construction using the Green-Schwarz formalism, in which the world volume is only bosonic, whereas the target space is supersymmetric. Okay, but the resulting theory is supersymmetric theory, and the strategy to usually to construct single M5 brane actions which appear in the literature to construct an action which describes a six-dimensional chiral two-form field, which is one of the important fields on the L5 brane world volume. And this field, this field is quite tricky to actually construct. Once we get this under control, then we can extend to the full L5 brane action relatively easy. Okay, so the chiral fields are actually the field whose field strengths are self-dual. Okay, so I would say the two main types of six-dimensional chiral two-form theories. The first one is that the one which is non-manifestly diffeomorphism invariant, which means that it has got diffeomorphism invariant, but it is not so clear. Well, it was constructed by Henok Setterbohm, Terry Schwartz, and by Taiwanese group, and also with there is also some extension with my friend in 2015, Sheng Lan, and this kind of chiral two-form theory can be extended to be a complete L5 brane action. Okay, and the second type is now we want to have the manifestly Lorentz invariant, or manifestly diffeomorphism invariant, which means that the diffeomorphism invariant can be seen explicitly already at the level of the Lagrangian. By just a first glance, you can see that it is diffeomorphism invariant. But the price to pay is that you have to introduce an auxiliary field which has got no dynamics. Okay, and this is the famously known as the Ph.D. action by Pasti, Sorokin, Tonin, and there are some extension, and it is possible to make an extension to a complete L5 brane action also by PST. And also there are also some, it is also possible to construct different action which describe the same L5 brane action, but with multiple auxiliary fields, basically. Okay, and in the theory in these two types, there is an important gauge symmetry which is called a PST1 gauge symmetry, which can be used to ensure that the equation of motion is equivalent to the condition that free-form field strength is self-dual. Okay, without this, it is not so clear. Because the equation of motion is a second-order differential equation, but the self-duality condition is first-order differential equation. So this gauge symmetry is needed in order to kind of reduce the second-order differential equation to first-order differential equation. And actually, there are also other kinds of chiral two-form actions, and I think this is still a hot topic even today. And one of the chiral two-form action which I'm interested in is the very recent one, which is by Sen in 2016, and with some developments later on in 2020. Okay, so in this formalism, it is a very interesting formalism in which the chiral forms are not actually, they are not actually the independent fields appearing in the action, but they appear as composite fields. So this theory, the independent fields are the two-form field P and the three-form field Q, which are in six-dimensional curved space-time. Okay, and if one look at the action, then one can see that P has got the wrong sign of the kinetic term. So, and indeed, this theory has got some strange features which I'll discuss later. Okay, and okay, in the construction, Q is self-dual with respect to the flat metric. Although the theory is in the curved space-time, the Q is self-dual with respect to flat metric. So this is one of the first strength feature, one of the strength features that we have. And some certain combination of Q with the curve metric would give rise to a field H, which is self-dual with respect to the standard curve metric. Okay. And at the equation of motion level, H is closed. So this H field is what represents the degree of freedom of the self-dual field of the self-dual tree form that we want. But actually, in the sense theory, there is also another degrees of freedom, which is the another self-dual field, but it has a long sign of that of kinetic term, and it is also self-dual with respect to flat metric. Okay, these two self-dual fields, they are actually decoupled from each other, so there is no problem with the appearance of the field with wrong sign of kinetic term. Okay, and actually there is another interpretation which is a more recent interpretation which comes, I believe, comes like this year or maybe a bit earlier, and I would prefer a new interpretation of this, but maybe I will give a talk about this later. I mean, in the later talk. Okay, but let's keep up with this interpretation for this talk. Okay, and it is possible to extend the formalism for the chiral to form field to the complete M5 brane action, although the coupling of the fields to the gravity is very complicated. Okay, so I mean, although the action has been fully constructed, some understanding would still be needed in order to make clear of how these P and Q actually couple to the gravity. I mean, we can say that we can write a very complicated equation, but it will give us not much insight. Okay, so we have to investigate this more. And okay, so this is the ultimate goal. But the goal of this work is just to try to work out double-dimensional reduction of M5 brane action to understand better. I mean, with the hope to understand better about how the fields are coupled to the gravity. Okay, so first I will talk about the covariant action for a linear self-dual field. I mean, by Sen. Okay, so we consider a six-dimensional space-time and with coordinates x mu, where mu runs from 0 to 5, and have a curve metric G mu nu, and define a differential P form, which I mean we will need a lot of differential forms in this talk. And as I have mentioned before, there are actually two kinds of metrics which we have to concern. The first one is the standard metric, the standard curve metric with the corresponding standard Hochstar operator. Okay, we have got the standard rule for the Hochstar. Okay, and there is another kind of metric which is the flat metric. Okay, and actually there is a further development on this, which I will review hopefully in the next talk. Okay. Okay, so but for now we have another metric which is a flat metric, and the corresponding Hochstar operator is corresponding to the flat metric. Okay, so it's defined with respect to the flat metric. So the Sen action is given by this. So there is a kind of like a kinetic term of P. Okay, but with the wrong sign, because in order to have a correct sign, you have a minus, you need the minus sign in front. Okay, and there is also some, would say, some coupling between Q and P, where Q is satisfies the self-duality condition with respect to star prime. Okay, and there is also some extra interaction term. And if we consider the variation of this interaction term with respect to Q, then we can write it in terms of the R, where by the rule, since Q is star prime self-dual, then R is star prime anti-self-dual. Okay. And then one would also define a field H, which is equal to Q minus R. So in the sense, this field H is a combination of Q with the background metric. Okay, and this H is demanded to be self-duality form. Okay, with respect to the standard metric, and actually these two conditions, the star prime anti-self-duality of R and the star self-duality of H, would completely fix the R. Okay. So we would obtain the quadratic theory in the Zen formalism. Okay, and one can work out the equation of motion by varying with respect to P and with respect to Q. So we would get equation 2.7 and 2.8. And if one eliminate P from equation 2.8, then one obtains this equation, which suggests that H, which is originally self-dual with respect to the standard metric, it is now closed, which in the space-time with no holes, basically, or in the space-time with trivial topology, then H is exact form. So which means that H equals to D of something, and that something is the chiral two form field, which is respect to the standard metric G. Okay, and as I have said before, that there is another degrees of freedom, which is the another self-dual form, another self-duality form field, but this guy is self-dual with respect to the star prime or with respect to the flat metric. And furthermore, the kinetic term of this guy, I mean, although it's not clear at this point, it's not clear yet at this point, but one can show that. Maybe I will give a talk about this later in a later talk. The kinetic term, if one can write the Lagrangian, then the kinetic term of this guy has got the wrong sign. And the good news is that this guy is decoupled from our physical self-duality form field. Okay, which is so we don't need to care too much. Okay, and actually, if we have a look back at the action, and then we want to ask what is the symmetries, in particular, what is the diffeomorphism symmetry? Well, the theory is diffeomorphism, but okay, let me go back a little bit. The theory is diffeomorphism, but you can see that the interplay between two metrics would make them not easy to see that this is actually diffeomorphism invariant. Okay, and actually, this is indeed the case. I mean, the field Q, P, and Q, they transform in a strange way under diffeomorphism invariant. And again, there is an updated point of view on diffeomorphism invariant given by how whose paper is published maybe at the beginning of this year, and I will give a review in later talk when available. Okay, Anyway, so I mean, if these were the standard diffeomorphism rule, then they would have been the just Lie derivative. But as you can see, that these are far from Lie derivative of each of these fields. So the rules are non-standard. But what one can show that by making this variation, then the action is satisfied. So the action has got diffeomorphism invariant, but not in the standard way. Okay, so next talk about the extension to nonlinear theory. So basically, the first two terms are still the same, but we are going to modify the last term. And also, we would introduce the three-form source term, which is called J. Okay, and the variation with respect to Q would still give the R. Okay, I'll call this piece as R, where R is still star prime and pseudo. And the equation of motion can also be derived, and it suggests that so Hj minus J is a field strength of some field, basically. Okay, and furthermore, we also see that there is also the combination Hs, which is the unphysical pseudo field, which is also decoupled. And at the off-shell level, we would demand that Hj is nonlinear self-dual. Okay, so basically the promotion from the previous topic was to promote the star self-duality condition to the nonlinear star self-duality condition. So instead of the right-hand side being just simply Hj, it is some complicated function of Hj and also of the metric G. Okay. And it can be worked out by demanding that the action has possessed the diffeomorphism invariant, and then one would obtain this action, where an important part is the function u here, where u depends on Hj and G. And there is also okay, so actually this term also appear at the linear level, and this term and the last term appear since due to the introduction of the source term. Okay. So basically, in the quadratic theory, the function u is equal to 0, and we will get every term in the action being quadratic. Okay, so next I talk about how to write the M5 brane action in the Green-Schwarz formalism. So basically, previously we have extended from quadratic theory to nonlinear theory, and now in particular we would introduce, there is a function u which is correspondent to the M5 brane action, which can be found to be given by this form, where where this is basically Hj contracted with Hj. And furthermore, we would also extend it to couple with the background 11-dimensional supergravity theory. So for the 11-dimensional target superspace, it consists of coordinates, which apart from the standard bosonic coordinates, where m runs from 0 to 10, so there are 11 dimensions, and there are also the fermionic coordinates, which are described by a spinner, which has got 32 components. Okay, and the fields are superview binds, okay, which would describe basically supergravity, and also there are also the three-form gauge superfield. And conveniently, one would also define its six-form dual. Okay, and these the superfields in the previous slide, they actually have to satisfy these constraints. Okay, and actually, only these pieces are required for the proof of the kappa symmetry, which I'm not going to show it. Okay, so then having described the background 11-dimensional superspace, now we talk about the embedding of the 6-dimensional L5 plane world volume to the background 11-dimensional superspace. So the embedding would be described by the embedding function. So basically, the background coordinates are now functions of the world volume coordinates. Okay, and then we have got induced metric. Okay, and okay, and the world volume still contain the field P and Q. So these P and Q, they live on the world volume as we know from the previous slide. Okay, and there are also we may realize the source field J should be the pullback of the C3 from the background to the world volume. And so it is possible to just simply recognize J as simply the C3. Okay. And we rewrite Hj as F. So F is H plus C3, where H is given by Q minus R. Okay, and then we also need the West-Seminole term, which is demanded by the gauge symmetry requirement. And it turns out that we only need to add the C6 term. And yeah, so the action would now be invariant under this gauge transformation. So basically, this is the resulting complete L5 plane action in the same formalism. And one important symmetry to show is the kappa symmetry, which is a symmetry which is used to ensure that the number of degrees of freedom of the boson and fermions are the same. Okay. But I'm not going to go into details here, but the idea is that one has to work out what is the kappa variation on the P and the Q, and this is possible to work out, basically. Okay, so having explained the M5 plane action in the same formalism, so now let's talk about double-dimensional reduction on a circle. So by double-dimensional reduction, it means that we make a compactification. So on both the world volume and the background target superspace. So basically, the world volume is 6-dimensional. We compactify on a circle. Okay, let's say the X5 direction is compactified, it becomes a circle. And at the same time, let's say the 10th direction of the background superspace, the L of the background space-time is compactified on a circle. So it's kind of like the background is compactified on a circle, and we wrap the M5 around this circle. Okay, so double-dimensional reduction means that most of them are compactified, both the world volume and the background. Okay, but first we are going to just simply make a dimensional reduction on the world volume theory only. Okay. So just think of just only think of a 6-dimensional theory and just compactify the X5 direction on a circle by identifying X5 with let's say X5 plus L. Okay, and we have got another parameter R appearing in the metric. And by dimensional reduction here, it means actually the KK reduction, which is like we set every field to be independent from the compactified direction. Okay, and we are going to denote the 5-dimensional coordinates by using the Roman alphabet. So, after the dimensional reduction, it would be convenient to separate the index mu to the AB5. Okay, so for example, the Q is separated into QAB5 and QABC. But actually, due to self-duality condition, the QAB5 and QABC, they are actually related. And the only independent components we can choose to be QAB5. So actually, or you can see that Q has got 20 components, but due to self-duality condition, 10 components are related to the other 10 components, and we choose the 10 components to be of this form QAB5. You can actually check by simple counting that 5 times 4 divided by 2. Okay, so which is 10. Okay, and similarly for R, we can pick 10 components, 10 independent components of R. Okay, and these Q and R are related by R equals to MQ. Okay, so we first consider the case of the quadratic theory. Okay, so we separate the P, okay, in this way, and okay, I mean we also separate P, right? P mu into PAB and PA5, and the derivative also. And you can see that derivative with respect to x5 is equal to 0 because due to dimensional reduction or KK reduction, we demand that the field don't depend on the x5. Okay. Okay, so we have got this action. Basically, you can see that this is an action for PAB, PA5, QAB. And the idea is actually by the paper. I have to say that actually I will follow the idea from this paper, but will change slightly the very last stage. So the idea is to try to dualize the PAB by introducing the XABC to be the basically the field strength of the P with respect to the 5-dimensional space. Okay, and yeah, of course, when we replace using this replacement, we would need to demand that X is closed. I mean, in the 5-dimensional theory. Okay, so after the replacement, so we no longer have PAB, but we have instead PABC. And also the Lagrange multiplier to fix the XABC to be closed in the 5-dimensional theory. And the idea is to integrate out the X, okay, integrate out the X and also the Q. So what we are going to have left are the K and the PA5. And one can see that it can be written in the quadratic form, okay, where I mean each term are of course quadratic in K and P, right? So we can put it in this form, and we can write the matrix A, okay, write this matrix A, which is just it looks like a 2x2 matrix, but it's actually bigger, but you can, okay. Is it 2? No, I think you can safely say that it is a 2x2 matrix. Okay. So basically, what we are going to do is we want to make a separation, and the standard way to see is to find the eigenvalues and the eigenvectors, so that we now can kind of get rid of the cross term. Okay. So we are going to, so the goal is we want to have two terms adding together. But in the equation 5.35, you will see that there is a cross term also. So what we want to do is to separate into just only two terms, okay, without a cross term, and it is possible. And we make this field redefinition, which is actually different from the paper that we follow. And we prefer this field redefinition, because one can see that the action completely separate into two terms. Okay? And these two terms, each of these terms describe the kinetic term. So if you have seen the Maxwell theory, Maxwell action, so you would immediately recognize that this is just simply the Maxwell action. Okay, and this is the Maxwell action with the wrong sign. Okay, so in the reduced theory, we see that we have got two Maxwell theories. So one has got the correct sign, and the other has got the wrong sign of the kinetic term. And these two fields, they decouple from each other. And also there is one thing to mention is that the standard Maxwell term there is 1 over R dependence, so which is the scaling required by conformal symmetry. Okay. Yeah, and we can also see that if we look at the Ph.D. Formalism and then try to make the dimensional reduction in the same way, then one would also see the 1 over R scaling. Okay, so this is a consistency check. Okay, and then one can now extend this method to the complete L5 brane action to obtain the D4 brane action. Okay, so basically, in the full theory, after the pullback, the fields on the wall volume that get pulled back to the wall volume are the G mu nu, C3, and C6. And after double dimensional reduction, these three fields become the metric on the 5 dimensions, and the dilaton to form B field and the odd form C field. Okay, and the induced metric on the M5 brane action on the M5 brane is reduced to this form. Okay, which would include the metric, the dilaton, and the one form C field of the type 2B of the type 2A supergravity theory. Okay, and the C3 field is separated to the lower dimensional field as the two form C field. Okay, and no, actually this is not two form C field. This is the two form B field. Okay, and the three form C field in the, and also the C6 in the 6 dimensions. After the pullback to the 6-dimensional theory, and after making the dimensional reduction, it becomes the C5. Okay, so we have all the fields we require. Okay. And now we would do the same. To the M5 brane action by also introducing the X field and introduce the appropriate Lagrange multiplier to make this field exact or basically closed. And then we integrating out X. And I would say maybe let's do it quickly, that we try to integrate out both X and T, but maybe in
การจับ
Okay, sorry. Maybe I repeat a little bit. So basically, we have got the M5 brane action, and then we make a we basically treat PAB by the XABC and introduce the Lagrange multiplier to make X being closed. Okay? And then we integrate out X and also integrate out Q. Okay? I will talk about everything in one go. And then we make a field redefinition. So the K plus P becomes basically the gauge field A, and the K minus P becomes basically another gauge field A, and which is, I mean, what we expect is that this A should have the correct kinetic term, whereas this AS should have the wrong sign of the kinetic term, and they should decouple from each other. And indeed it is, but okay, there is also some technical details which we have to rewrite the U. Okay? But anyway, the end, I mean the upshot is that we have got so psi is the field strength of the gauge field AS, which previously we see that it has got the wrong sign of the kinetic term. It is basically the Maxwell field, but with the wrong sign of the kinetic term. And we can see that these AS, they do not couple to any other, they don't reappear into any other term. So we can just get rid of this guy, okay, which is a good thing. And also the physical field is given by the dBi action and also the Resumino term. Okay, so this is basically the complete deformation action. Okay. In the type 2A super gravity background and in the Green-Schwarz formalism. Okay, and actually in the paper, we also talk about dimensional reduction of M5 brane action in the same formalism to another description of the D4 brane, which is the dual D4 brane. So basically, instead of trading P, so what we did was to trading PAB by XABC, right? But in order to obtain another description of D4 brane, we trade PA5 okay, by YAB, and follow the similar steps. Then we get another description of the brane, okay, which agree with the with the action already present in the literature. And we have also made some proposal for the other double dimensional reductions of the M5 brane action, not just only on the circle, maybe on some torus, but still haven't worked out in detail. And as a conclusion, so we can see that the dimensional reduction of M5 brane in the Sen formalism naturally gives rise to either D4 brane action or the dual D4 brane action. So we can just simply follow the same process, but just slightly change of the initial step. Okay. And it is also possible that double dimensional reduction of M5 brane in Sen formalism would naturally give rise to other brane action, which we will have to work out. So it looks like the Sen formalism is really quite favorable in this sense. Okay, and we have got some more ambitious future work, which is to try to see relationship between different formalism of M5 brane theory or of the all of the chiral form theories. Okay. So in particular, there is a recent work that we are working on is to relate the Sen formalism with the gauge fixed Ph.D. formalism with two of my students, and it is still being in the with the journal. So under review. Okay, so thank you for your attention.
Okay, thank you very much for a talk. If there are any question here on site or the online, so if there are any question here,
I just wonder that the way that you pick a choice for the field day definition, actually you mentioned that you chose a different one, right? From the previous case.
So you mean
So slightly different.
Slightly different.
Is that because you want to make the kinetic term separable? Is that right?
Okay.
Yeah.
You mean
yeah.
here, right? Okay. Yeah. Because okay, good question. So actually, in this paper, they also made a field redefinition, but yeah, the two terms are also separated. But what the feature that we don't like is that in their work, this is a function of R, which I'm not sure which limit. Maybe R goes to 0 or R goes to infinity, that they recover 1 over R. But here I prefer it because we get 1 over R scaling no matter what the value of R is.
Right. So you need a kind of different feature at the limit of the R. Then you that is the reason why you choose different choice. Slightly different, right?
Yes, and it's actually more intuitive that we just try to do the standards undergraduate mathematics to like just to find eigenvalues, eigenvectors, and then get the field redefinition just suggested from that.
Okay, thank you.
any questions? Okay, probably more general question. What are different feature between like D brane and M brane? Because in your result, you justify your result as a dimensional reduction from M5 brane goes to D brane, something like that. So how can you justify that, and basically what are characteristics or feature of M and D different?
Okay, so I would say that the most one of the most basic feature is the field content. So let's say on the M5 brane, there is no there is no one form gauge field. Right? I mean, but on the D brane, as you know that the whatever the D brane is, there is a one form gauge field on the D brane. But for the M5 brane, we have, maybe not, but actually one of the field content of the M5 brane is the two form gauge field with three form several field strength, which is quite different from the D brane. And also, if you look at the M2 brane, there is also no gauge field on the M2 brane. So I would say that one thing is the presence of the gauge field, and this is related to the fact that in the string theory, you can think of the brane as the place where the endpoint of the string has to attach. But in M theory, we have got no string. So basically, we don't have the gauge field on the we don't have the one form gauge field on the M brane.
So is like in the five band you have the chiral two form which is P, right? Is it P field two form P field?
So it's actually a bit more complicated than that. So I would say that is the field whose field strength is H. Okay. Because in this description is a bit complicated that the degrees of freedom is not described by the independent field, but they are rather the composite fields. They are composed of the independent fields of the theory. So H is composed of basically P and Q. Okay, so you can think of it as like combining P and Q in some complicated way, and then get this three-form field which is self-dual, and the corresponding gauge field is therefore the two-form chiral field.
Yeah. I'm trying to think that you mentioned that in DP band, you say that there is one form that consists of one form gauge field, but for the case of M5 band, the only field that have two forms is P, right? So for the dimensional reduction, you reduce, is it directly reduce P to A, something like that?
Good question. No. So it's actually one has to combine it with the Lagrange multiplier. So yeah, so you see that combine in this way.
For another naive question, why do you need to impose the cell dual condition to the edge? I mean, it's like, for me, it seems like you apply it and see what are the results from that, isn't it?
Okay, so well, is how do I explain it?
Maybe
Yeah.
let's start from this.
Yeah, so basically the degrees of freedom you want to describe is two-form field with self-dual field strength, right? But it is not possible to just simply put the field. Let's say you cannot just simply write H with star H, and then define and then demand that H equals to H is being self-dual. Okay, so what in the literature has done, or in the main method which has done, is that to give up the manifest diffeomorphism invariant, write down some action, and then what one wants is that one have got H which is a field strength, but H is not self-dual. The self-duality is obtained at the equation of motion level. Okay? But for the Sen formalism, the thing is switched. Okay, so in the Sen formalism, instead of having the field being the field strength at the equation of motion level, one wants the field to be a field strength at the equation of motion level, okay, and impose the self-duality condition at the action level. I'm not sure if I answer your question.
Okay. If there is no further question, I would like to say thank you for our speaker, Ajahn Bhat, and yeah, that will be the end of the seminar. Thank you everyone for joining, and stay tuned for the next seminar to come. Thank you.
Thank you.
ภาษาไทยแล้วกัน so we for everyone who join here please fill in the satisfactory survey and for the audience online please please fill in the satisfactory survey that appear in the comment section. The link are in the comment section. Thank you.